Junior door. You press the button, right? 540. We start now. Okay. Okay, let's discuss it in detail. The question 3. I suppose we start, but we don't finish, no? Yes or no? Positive or negative? We don't finish, right?
We stopped at number.
Number what?
F3, no? F3.
Okay.
Yeah, we stopped
okay,
at F3.
Okay. Okay. So this is a piecewise function. Number 3. Okay. Good. We start at the beginning. I don't know if you explain something or no. No. Okay. The interpretation of this. A piecewise function que contain 3 pieces. Let me use in 3 different colors.
Professor. I wanted to ask you a question. For these questions,
come on.
It has to do with this topic that we're doing. How do you know which number fits with which equation?
Well, no, this is given. O sea, es given the entire piecewise function, and it's given a specific at that number. If you want, we include more number if you want. But this is the given. Everything I put in the whiteboard is given except the number line, no? This is your question, miss?
That's my question.
Yeah, okay. Okay, so let me explain. Pay attention.
Okay.
Look at the... I can interpret this piecewise function that contains 3 expressions. The blue expression que corresponde with the blue condition, ¿no? The green expression que corresponde with the green condition. So any value inside this interval you evaluate here, you select. So there one first process que is selection. It's a yellow. Suppose that you want to evaluate this negative 2. Okay. One, way to visualize this idea is, for example, blue color is less than negative 2. Less than negative 2 is this interval. But of course, do not include negative 2. So parenthesis here. Because I don't see any equal sign here. No equal sign, no include negative 2. The green is in between the negative 2, include negative 2, bracket green, 2, 3. I do not include 3 because it's not equal, entonces paréntesis. Green paréntesis. And yellow is bracket yellow to infinity. Any value that lie inside this interval, we have to use this expression to evaluate the function. Because the blue expression corresponds with the blue interval. Any value que lie in the green interval, we use in this expression. And any value que lie inside the last yellow interval, we use in just 4. It's a constant function, 4. Okay. Okay, more clear this interpretation or no? Or is this confusing? Confusing, clear, confusing, clear, confusing, clear. Clear, confusing.
Clear.
Okay, unclear. Clear, unclear. Entonces, it's clear. Entonces now, bueno, okay. For negative 2, I suppose negative 2 is here. But negative 2 is confusing because negative 2 is the transition point between blue part and green part. But it's obvious que the green part because of the bracket. So we're using this expression. We select the green expression. We select x squared plus 1. But you evaluate in negative 2. Entonces one notation, personally, I like a little bit. You put this symbol, it's like a such that, and you evaluate a negative 2. Plugging in. Entonces, negative 2 square plus 1. Negative 2 square is positive 4. Positive 4 plus 1 is 5. And the answer is 5. So 5 is the answer for this. I don't know. I write here in a small space. Shoot. Okay. Let me magnify this. Make it zoom. Zoom out. And erase that part. I don't know what happened. What's going on? Okay. Slow motion. Next guy is F evaluate in 0. F evaluate in 0. 0 here. 0, they again belong to this interval. Okay, one more mathematical idea is 0. So you must replace x for 0. Look, 0 is in between negative 2 and 3. This statement is true or false? This statement is true or false? It's obvious it's true, right? It's true. Therefore, satisfy perfectly. And one more time, we select the expression green such that x now is 0. The 0 squared plus 1 is 1. Now evaluate in 3. When you evaluate in 3, 3 is here. Again, 3 is a complicated point que maybe it's confusing, no? Pero es obvio que 3 is yellow because the yellow bracket is here. That's the reason. So another way is visualize here greater than or equal to, no? Suppose que you replace 3 here. 3 is greater than or equal to 3. This statement is true or false? This statement is true or false? It's true, of course, it's true because it's equal, right? Entonces you, si es equal, you take the yellow expression que es just 4. And not necessarily any computation because it's a constant function. And constant function do not depending on x. The next is 0, 1, 3, and negative 3. Negative 3. F and negative 3. Negative 3 is here. This is negative 2. Negative 3 is obvious here. Negative 3 lie in the blue part. Entonces, the expression que I select is minus 3x plus 2. Such that x equals minus 3. Substitution is minus 3 and minus 3 plus 2. This is 9 plus 2, 11. Go. Final answer, final answer, final answer. Now f and 5. Okay. Forget about here. Here. Let me copy in another place. And 5. And 5 is, this is 4. This is 3. This is 4. And this is 5. 5 lie in the yellow part. In the yellow part, the function is just 4. And do not depending of x. And finally, a negative 4. A negative 4. A negative 4 is here. And the blue part, this is negative 3. And negative 4 plus 2. The 12 plus 2, 14. Final. You get the idea, or you need more points? Because I can. Hello. For example, I evaluate in, let me see. I evaluate in 1. I evaluate in negative 1. I evaluate in 2. I evaluate in negative 2. No, in negative 2 I did that. In 2 positive. In 1 and negative 1. In 1/2. Why not? Okay, enough. Who helped me to evaluate in 1, for example? And 1 is, where's 1? Here. This is 0, this is 1, 2. 1 is here. Belong to the green part. No? So you select x squared plus 1. at x equal 1. 1 squared is 1 plus 1 is 2. Negative 1. Here. This is negative 1. It's exactly the same. X squared plus 1. Pero now evaluate negative 1. Negative 1 is squared. Be careful with the parentheses plus 1. Again, it's 2, no? Because negative 1 squared is 1 positive plus another 1 positive is 2. And 2 is here. Again, green. Entonces es x squared plus 1, evaluate at 2. Es 2 squared plus 1. 4 plus 1, 5. And 1/2. 1/2 is, I suppose, 1/2 is in between 0 and 1 here in the middle, 1/2. Belong to the green again, so we're using the same. X equal 1/2 is 1/2 squared plus 1. 1/2 squared, 1 over 4 plus 1. 1 over 4, 1 is 4 over 4, is 5 over 4. Leave it like that or in decimal, either way. Entonces, guys, it's easier. The only thing you should do is investigate in what interval lie the number of the value belong to the domain. Entonces, you select, procedure of selection, what expression is associated with this interval. In this case, put a color to illustrate in a funny way, blue, green, or red. And just substitution the value. End story. Super easy. One question like that. Of course, more easy than this. We discuss it complicated. And then you say, wow, too easy. Any other question? Please. This is a review. This is a moment to ask me a question. Well, unfortunately, face to face, Professor, I don't remember. No.
I understand.
Okay, super. That's exactly what I want to hear.
The chart that you draw in colors help me understand better.
Okay, super. Well, okay. This is one resource. If you want, you are doing this. You separate the Orion number line in different interval. In this case, we 3 interval. And you put inside different color. And you associate with the expression in this interval. And that's it. The rest is selection. Okay. Number 4 is a little bit more complicated. Why? It's a little bit more complicated because this is also piecewise function. Let us now do the graph. In the lecture, I explain using decimals, but I want to explain now using both. Suppose we are in the jungle without internet, computer, only one piece of paper and one pencil, and we are doing the graph of the piecewise function. Now, after we use technology, I go to decimals, we are doing decimals, and compare both answers. See, is everything okay or no? We are doing okay, or I make a mistake. And number 4 is the same piecewise function, but now we are doing the graph. Do the graph of the following piecewise function. The name of the function is f. But fortunately, we have only 2 pieces. So in the test, you can find 2 questions. Guys, one question can you evaluate in 3 pieces, more complicated, and one question can contain 2 pieces and do the graph. Similar to the review. Okay? If the condition is x less than 1. And just for if x is greater than or equal. Okay, let's do it. Okay, I have my rectangular coordinate system. Let me try to find image. Okay, I have one image here of the rectangular coordinate system. Okay, I copy here. ready to start by hand. Okay, let's do it. I understand that we have one piecewise function that contains two pieces. Again, the blue piece that corresponds with this condition, and again, the green expression that corresponds with the green expression. Okay, okay. Now I do the graph one by one separately, like that. Suppose y equal minus 3 plus x. Okay, I have no idea. Well, I suppose que es a line, no? It's a linear function. Okay, it's a line, but I have no idea how it look like. But I remember something, y is equal to mx plus b. I suppose you remember that. And this is similar to this, except that you put, for example, here, x minus 3, no? I switch it, no? A little bit. I put the x in the first place, the 3 in the second place, and minus. Therefore, you associate immediately that our b is minus 3. And b, I know, can represent the y in a set of the any linear function. Actually, it's 0, negative 3. Because it is on the y-axis, the x component is 0. Yeah, I plot that point. Oh. Now, I can see also that the slope of this line is 1, because I don't see any coefficients. Yeah, I suppose the slope is 1. And the interpretation for the slope, I suppose that you see this in Cole algebra. In Cole algebra, no, in intermediate algebra, sorry. The interpretation for the slope is the ratio between rise and roll. In this case, equal 1, and 1 is a whole number. Therefore, 1 is 1 over 1. So wrong is 1, and rise is 1. It's a coincidence. So from the given point, okay, what's this? You wrong, you want to rise first. 1 unit up, because it's positive. 1 unit up. And 1 unit to the right. And we get the second part. Okay, by the way, this point is 1, negative 2. And we're connecting both points by the line. Only using the rule. Using the rule. I rotate the rule. Okay, I move the rule. Little b, no, in that opposite direction here. Good. Yeah, do the graph. Do the graph using dotted line maybe. Why dotted line? Because this is auxiliary construction. This is not the final answer. This is auxiliary. Now, the only thing we are doing so far is do the graph of this line. That's it. No more. Everyone follow me? Everyone understand very well? In the test, I put another value. Image. And the test, maybe I put another value. I put no minus 3 plus x. I put 5 plus 2x. So you will be able. Please.
Where did you plot? You plot the points at -0, -3, and you made a.
Because I discovered that b is -3. Do you see that or no?
Yes.
B. Therefore, I know that b always is y in a set of the any line. And y in a set lie on the y-axis. And at any point on the y-axis, the first component is 0. 0, b. In our specific example, b is -3. Super? Super or no?
Super.
Eso. Okay, entonces from this point, according to the wrong and rise, depending on the slope we have in our problem, you discover the second point, and we using the rule connecting both. Okay, let's move on to the second function, que is just 4. Wow, it's a constant function. I can write like that. I represent in my mind like that. Y go 4. And Y go 4 represent horizontal line passing through 4. At any point here, 4, 4, 4, 4, something common 4. Okay? It's horizontal line. You know that. Okay, no problem. I use my rule. I put 0 degree, 0, 0. 0 degree because it's horizontal. Carajo. 0 degree. I need to roll the wheel of, no, to move the rule. 0 degree, nice. Now I click in the mouse, move here, 0 degree horizontal. And also I using again dotted line because this is auxiliary. I don't know, I using green, but it doesn't matter. I don't care what color. The color is not important. The color is not important. Okay, super. Now, what are you doing now? Well, we are doing the graph of two expressions separately. Okay, I suppose that we have no relationship. No. I do the first part. It's a line. And the graph of this is this. Minus 3 plus x equal y. And the graph of this is this. Y. Everyone follow me so far? The other time, almost we are finished. Okay, now I want to do another dotted line, okay, the condition. The condition, we have only one, one, positive one. And positive one, so the line, let me put a 90 degree, the rule, 90 degree rule. I move it to 1, 90 degree. Okay, I put in 1 here. Okay. In this case, intentionally, I use in black color. Okay, I put dotted line, and this dotted line is split. It split the plane in two semi-plane. The left semi-plane and the right semi-plane. Okay, and the right semi-plane in that direction represent x greater than or equal 1. So this condition. And in the opposite direction is x less than 1. Okay, well, now almost ready. I want to using another color, maybe the final answer. I want to put in blue color. Okay, let me using in blue color. Let me using this, que es a little ball, I suppose, no? Okay, entonces, look at that. To x, let me try here. Okay, nice. Suppose que x less than 1, que es that case, this plane. We travel, we navigate for this expression. And this expression corresponds with the line. So basically, we navigate for this. Let me try to do my best and my hand right. Stop here. And this I suppose can continue forever in that direction. No, not good. Not good my drawing. Okay, look. Line. Stop here. I don't know exactly what happened here, but this I know can continue forever in this direction. Okay. After that, greater than, so you switching to the 4, and 4 is this. And this continue forever in that direction. Now, what happened exactly in this point and what happened exactly in this point? Depending the equal sign. And the equal sign, what is 4, okay, here, is 4, equal sign. This circle is totally closed. And this circle is totally open because in the line, we have no equal. End the story, I finished. What is my final answer? My final answer is the blue part. Any question? Okay, see, I try to summarize everything we are doing is, you consider the piecewise function like a 2 or 3 or 4 independent expression. Yeah, you do the graph separately of this expression. Pam, using dotted line because it's an auxiliary contraction. After that, I using the condition, in this case was 1, it's a transition. I call transition. Transition is when the piecewise function jump. And this is the technical name of this is jump discontinuous. So this step, bang, is jump discontinuous. Eagle. O-U-S. In this moment, I split the plane, the famous XY plane, in two semi-planes. They are before one and after one. Okay? Entonces, I know que before, this is before one, our function f travel for this line. I did that. I don't know exactly the transition point. This is the last moment. After, this is after one, I include one, we travel for 4. Okay, specific in 1. What happened in x equal 1? I go back to the piecewise function. I see that 1 is equal here. Therefore, the circle closed belong to the 4. And the circle open belong to the line. Done. Final answer. Any question? Come on, I want to hear a question. Or no? Or everything is okay? We are the best in Miami-Dade College. Carlos Florentino, Cesar Dominguez, Minerva Perez. Okay, thumb good. Thumb up. Okay, that was Rosalinda, no? Okay. But no. It's not enough. I want to get 100 points in this test. Therefore, I open decimals. I try to do in this. If you want to learn, I want to explain now. Okay. Okay, this is a board. I want to switch into the board. Switching to decimals. This is decimals. Switching to decimals. Switch screen to the window of the decimals I prepare for you. And we are doing from scratch. I have nothing here. Nothing I have. Okay. Entonces I copy my first piece. Is Y. I'm using the keyboard. Look, I like Y is equal. Double equal, no. Only one. Minus 3 plus X. Oh, it's a line. This is the famous line. Remember that we plot. You remember, guys? Look, the Y and it says 0,3, and we navigate right 1, wrong 1. That point. And we using the rule. Another important point is 3,0 is the X in a set. This is the Y in a set of this line. But no, I don't want the entire line. I want specifically, so you put here that symbol. That symbol you can find in ABC, that symbol, look, que es a curly bracket. So you put X less than 1. And decimal only draw the specific piece que we need. Less than, before 1. Remember, this is 1, look. 0, 1, 2, 3, 4, and 5. This is 1. Okay. So fantastic. I like that. Now I press enter. In the next line, I put a 4. No, it's the second piece. It's 4. And 4 is valid. Let me see the keyboard again. 4. Okay, no, sorry. It's Y equal 4. I forgot the Y. Y equal 4. And you put a condition. And the condition you put using that symbol, okay, is X greater than or equal 1. Let me see. Oh, look at that, baby. I don't like different color because it's the same function. So I need to make a decision what color I prefer, blue or I prefer blue. So I change the color here. I press all the mouse, select blue. Blue. I finish now because I need to indicate this is important. You leave it like that, 0 for you. I need what's going on specifically in the transition point. One transition point at least I can see is the point 1, -2. I don't know if you see clear or not. Look, 1 in X, -2 in Y. So -1, -1, no, +1, comma, negative 2. Boom. Again, blue color, and this is the open circle. And the second point is the 1,4, the second point. Of course, I need to put in another line because it's totally different. It's 1,4, 1,4, and 1,4 if close. Again, blue. In this case, no blue, I change the color. Blue. Final answer. This is the answer I want. And they are perfect coincidence with the thing I try to do by hand on the paper. Any question? Any question? Any question? Any question?
Can we do it by hand?
Okay, you are doing in any way. Okay. The idea of the Desmos is always checking, double checking. Hypothetically, I suppose that you are doing everything by hand. Paper and pencil. And calculator, of course. And Desmos is a tool que es like one graphic calculator I have on my desk. Use it. That's it. To verification that the thing I did by hand was perfect. Clear? Any question? Any question? I need question. I need question. Because on the test I cannot help you. It's your test, not mine. I passed this class. Okay? Let's move on to the next question. Or no? Move on. Okay, move on. Next question. Switching to the board. This is the board. Piece Y function. I know very well. I get 100 points in piece Y function. Okay, let me delete, erase everything. Erase. Okay, let's go number 5. Number 5 is number 5 is do the graph. Do the graph of one function whose expression is minus x squared plus 1. And also day one. And also day one, can you find, this is complementary, y in a z and x in a z. Okay, the first job is do the graph. And the second is compute y in a z, que es el point, and x in a z, que es el point. I don't know si maybe 1 point or 2 points. Okay. My question is, you identification transformation in this function or no? Okay. What family belong that function? So that function I call f of x, I immediately recognize que belong to the family of the function x squared. Yeah, I know by memory is the parabola, like that. Even function, parabola. Okay. But we can see here two transformations. One minus here and 1 plus 4. Okay. According to the order of operation, the first transformation is this. And this is reflection, no? It's reflection. When it's a minus, it's reflection. But remember, we have two kinds of reflection. We have reflection when you put the minus inside the parenthesis, or when you put the minus outside. This is reflection about y axis, and this is reflection about x. I can see why I suppose that this minus is not inside the parenthesis, it's outside the parenthesis. So this is reflection like that. Chun chun. Okay, this is the graph that corresponds to y equals x squared. According to the first transformation, this graph is exactly the same as the image, but minus x to the second power. Okay? Everyone follow me so far? And plus 4. Plus 4 is you have a function and you adding 4 outside. It's not the same that you adding 4 inside the parentheses. Ashley Johnson started a call. Okay. When it's outside, it's vertical shift. Vertical shift. When it's inside, it's horizontal shift. In this case, I suppose it's this, no? This plus 4 is completely outside the function. But it's plus. Okay. When you talk about function, it's this function. After, okay? No, the original. The original include 4. Entonces es obvio, en my opinion, ¿no? Que es vertical shift. Y si es positive 4, es upward. Okay? At any point in this curve, moving up 4 units. 1, 2, 3, and 4. Something like that. I want to do more clear. I do roughly to understand the transformation. So basically, we had transformation number 1, that was reflection about the x-axis. And transformation number 2 was vertical shift. So my graph, my actual graph, sure, in my opinion, look like that. It's a parabola that is up and down from 4. 1, 2, 3, and 4. Like that, and like that. Remember, the parabola is a smooth curve, not like that. Boom, boom. This is wrong. Okay, it's a smooth curve. Hello, what do you want? Pay attention. I am doing the review. Don't interrupt me anymore, please. Ashley Johnson. How I'm supposed to join the call? Because I send the email for everyone always, like every day. Michael Aguirre started the call. You don't receive the email? Ovino Romero. I have your name. It's the same for everyone. I just copy any name and send. I send the email 10 minutes before to start. If you don't receive, immediately communicate with me. Okay, this point. Well, okay. I finished the first part. Can do the graph. Well, actually, a little bit confusing. Now, in order to find the y-intercept, remember function notation application, you evaluate the function in 0. And the function, remember, is minus x squared plus 4. This is a function. When you evaluate in 0, it's minus 0 squared plus 4. It's obvious that the answer is 4. And the y-intercept is the point 0, 4. Because the x, I suppose, was 0, and the y you get is 4. This point is the vertex of the parabola. It's the turning point when the parabola change is 0, 4. I have in my hand y-intercept. Another application of the function notation is to find x-intercept. And the formula that you need to memorize is f of x equals 0. This is a formula that you have to memorize to find any x-intercept we're using in the test 3, in the next test. Y-intercept immediately. What is the formula? F evaluating 0. To find y. To find x, f of x equals 0. To find x-intercept. This is the formula. Mnemonic device to remember. Okay, entonces you copy. Minus x squared plus 4 equal to 0. This is my function is equal to 0. Because in this moment, we have super elementary quadratic equation. And you solving the quadratic equation. And the quadratic equation, let me try. I move forward to the right hand side. Divided by -1. Both sides. Okay, apply square root both sides. And x without square root and square is plus or minus 2. Because square root 4 is 2, but we have to value, no? It's plus 2 and minus 2. Therefore, we expect 2 point que es 2,0 and minus 2,0. Let's suppose que 2,0 is this point. This is 0, this is 1, this is 2. 2,0, and this is negative 2, negative 1, negative 2,0. End the story, I finish. The curve is the parabola que es up and down and have one y-intercept at the point 0,4, and also when the up and down cross it, the x-axis in 2 points, que es the x-intercept, que es 2,0 and minus 2,0. But just in case I want to verification in this one, because I want to get 100 points in this test. Any question? Any question? Ashley, are you there? Ashley Johnson. No? I have one group of students that don't care anything. But don't worry. Next time, in the second test, is your last test, I suppose. Okay? Any question? Any question with respect to question 5? No? Do you want que... No, okay, good. Do you want que it's convenience doing the in decimal or no? No? Yes or no? Let me know. Always is good doing this. Yes, of course, yes. I love you. Yes, decimal. I love you. I love you. Fantastic. To verification. Yeah. Junior door. To verification. To verification. Let me see. Wait. Let me switch into decimals. The screen. Switch into decimals. Okay, there you go. Window decimal. Okay, super. Bueno, I can delete that part. You can delete the piecewise function was history. If you want to save, you can save. I suppose I explain one moment how you open the folder. You open the folder, for example, you open the folder here. Open the folder, you put, this is a question number 5, no? Question 5. Question 5. So inside the question 5, I have the function, okay, remember the function was y equal minus x squared plus 4, no? Look at that, my parabola. This is my parabola. And my parabola up and down. And when you click on the curve, it's unbelievable how Desmond understand that this point is important. Look at the y-intercept and look at the x-intercept. Papa. End the story. I finish. If you want, you can put it here in another color, no? Remember the point 0,4, boom. And you put a label to indicate, and you put another point separated by comma, que es 2,0. Okay. Another guy separated by comma, que es minus 2,0. Super. Done. No problema. I can verification perfectly. Any question? Okay, this look like easy, no? The next, no. The next is very, very weird, complicated. Yeah. Any question? Any question? No? No? Everyone follow me? Okay. Okay. Let me switch into the board again. Switch into the board again. It's the board. Switch into the window for the board. Okay, no decimal anymore. This is the board. Let's move on to the question 6. Question 6 is a little bit weird. Let me try. But I need help, a little bit. Help. Question 6. Question 6 is, again, do the graph. But I need to identifications if we have some transformation or no. Ajá. Y ahí incluye extra. Ahí incluye extra. Ahí incluye fine and also in the review packet, I don't write that, but I want to discuss this. A y in a set and x in a set. It's the same thing. And the function is g. The name of the function is g. And the function belongs to the family of the square root. Square root minus x plus 2. I know that the graph of the square root function look like that. Open in only one direction. Because the domain is only positive number. A negative number is totally out the domain because I know the square root negative number is imaginary, and in this plane, xy plane, only I plot real number. So x and y both are real. No I, there are no I, it's impossible. When you see I, it's because living in another dimension. Okay? Now, this is the basic square root without transformation. But I see two transformations here. I see wait. I see here dot minus, que es reflection. Reflection. Both. Reflection. But what kind of reflection? Reflection about the y-axis or about x-axis? Well, I suppose it's about y-axis. Why? Because reflection about y-axis is when you put a minus inside the parenthesis. In this case, we have no parenthesis, but we have grouping symbol. It's similar. It's similar, no, it's the same. So not necessarily parenthesis. When you talk about parenthesis in general, it's a grouping symbol. Grouping symbol is parenthesis, it's a bracket, it's radical, it's grouping symbol, absolute value. There are different grouping symbols. And this belongs to this. So this minus inside one grouping symbol, so I suppose que the reflection is like that. Boom. This is the graph of the y equal minus, or minus, no, sorry, square root negative, square root negative x. Okay, let me erase that part. It's a square root negative x. Everyone follow me so far? Do you understand the reflection about the y-axis? Que es completely different. Si I put a minus here, if I put a minus here, the reflection is like that. Well, no. It's not the case. The minus is here. It's inside the grouping symbol. This is about the way. Entonces, now the confusing part. These two is also inside the parentheses. Yeah, I suppose that when you adding or subtracting inside the parentheses, we have horizontal shift. Yes or no? So the motion of this curve is horizontal. Fa. I don't know si es to the right or es to the left. Somebody say get right. What do you think? What do you think? Is right or left? It's confusing. Extremely confusing. Is left or right?
Left.
Is left. The common sense indicates it's left. However, it's not left. It's right. Let me explain. Sometimes happen that you cannot see the transformation immediately, and you need to manipulate a little bit. And it's a typical case in which you need to manipulate a little bit this to understand much better. So the manipulation is, look, g of x is equal. So you factor out minus outside, because this minus was the first minus that we use in here. We open the parentheses and we have x minus 2. Let me check if this idea is correct or incorrect. Okay, minus multiplied by positive and minus and double minus become positive. This expression and this expression are perfect equivalent. Yes or no? Now, this is a little bit more clear. Okay, we have reflection here. This is reflection. But this is not plus 2, it's minus 2. And minus 2 represents the horizontal shift 2 units to the right. To the right because it's negative. Yeah, I know theoretical. When you have a function, g in this case, and it's x minus 2, it's to the right. It's g, x plus 2, it's to the right. Do you see or no? Do you see or no? Confusing. I know it's confusing, but not always you can apply directly in one function the transformation. You need to manipulate a little bit. There are several examples. No, this is one example to illustrate this idea. That the majority of the case in the test is obvious. You see, go.
You're saying it's going 2 units to the right because it's negative?
And
Okay.
when you study in the lecture, remember that when there's negative to the right and when it's positive to the left. Do you remember this or no? This is right.
Yes.
Do you remember this? The problem is that it's not obvious. When you see in the origin, you say, plus 2. The plus 2, I remember, is left. No, because you need to modification a little bit. You factor out negative, perform the reflection first, que es the thing I did in the blue part, and after horizontal shift to unit. Okay, entonces after the last answer is I move the blue part to the right 2 units. So at this point, que es 0,0 should be 2,0. More or less, it's something like that. Yes or no? Okay, you move to the right 2 units, any point. This point, this point, this point, this point, this point, any point, you move to the right. After you see them, that's more clear. But this is roughly by hand. Do you understand the tricky part of this example? If you want, I can illustrate another example. Case you need to manipulate. So not always is obvious the transformation in one. So you need to manipulate to understand. Okay. The second part is determine x in a set and y in a set, no? Okay, to determine the x in a set, remember you take the function and evaluate 0. Square root minus 0 plus 2 is square root 2. And when you put in the calculator, so you want to see decimal approximation of 1.41. That the point is 0.1.41 or exact answer. This approximation in decimal. Radical 2 is irrational number, 0, radical 2. This is in decimal now. What is the? Because decimal always working in decimal approximation. And in order to find the x in a set, you take g and you put equal to 0. And g is square root minus x plus 2, no? I copied the original. You put it in force to be 0. Entonces, in this moment, we have a radical equation. But a super easy radical equation. You square both sides, which you want to eliminate the radical, minus x plus 2 equal to 0, because 0 squared is 0. Minus x is equal to minus 2, divided by negative 1 both sides. X is 2. And the point is the point 2,0, because remember the supposition was que y is 0. The supposition in y and z was que x is 0. But in the x and z is y 0. Yeah, I plot that point. This point I did. This point is this. So this point is 2,0, and this point was 0,1.41. It's radical. Y and z, x and z. End of story. I finish. Just in case I want to check in the now. Any question, guys? Any question? I promise that the test you see some weird example of that. One classical, like a number 5, and one confusing, like a number 6.
Can we take a picture Can you make
Take
it
a picture. Oh, take it. Make it soon, right? Like that?
Thank you.
Pleasure. Any question? Let's move on to decimal. Oh no? Yeah, of course. Why not? Number 6 question. 6. Okay. Yes, please. Flora, say yes, please. Okay, look. Andreina, yes. Okay, Desmos. Now switching to Desmos. Look at that. Okay, that was the question 5, no? I click here in this arrow. This contains the expression, and click here and delete. No delete, put on available. Now I create the question 6. I put the name, question 6. And question 6, remember, the function was y. You can put y, or you can put, if you want, g of x. Either way. Remember, this is equivalent. Y and f of x is the same, or g of x. The name that you want to put in the function is equal square root here. Oh, no double square root, only one. Okay, minus x plus 2. Minus x plus 2. Boom. Do you see the reflection? Okay, see, I try to summarize the reflection was reflection, the transformation, sorry. The transformation was reflection about the y-axis and horizontal shift to unit to the right. And the y-intercept is 2,0 and 0,141,4 using 3 decimal place approximation. Any question? No. No question. Wow. Or I am the best explaining the thing, or you are the best student I have in my life. Because normally, when I teach that part, nobody understands anything. No. I try. It's a good combination. Maybe it's a good combination. You are good. I try to do, and also I teach it several times. This to say I know any detail because I try to explain. Okay, number 7 now. Number 7 is, well, number 7 is a classical example. You can see humble. What means humble? I don't know this word in English. Humble. Translate is okay, I understand. No. Okay, I am human, and the human make a mistake. Okay? Humility. Okay. And a human make a mistake. Okay. Number 7 is the classical question in the test in which you determine algebraically whether the given function are even, odd, or neither. So we have several examples. Let's do it one by one. But the procedure is always the same. 3x squared plus x to the 6th power plus actual value x. The second is g is equal x cubic. Cannot see the board. Okay, sorry. Okay, good.
Still on decimal.
See, I know. Now, everything okay, Ana? Okay?
Yeah.
Good. Okay. The second is this. The third is H.
Decimal.
And Desmos. I switch, no? Or no? Yes. Do you see me or no?
Yeah.
No, I see it.
Maybe there are some delayed. Pero normally Okay, some delay. Yeah, I understand. P function is x squared over x to the 4th power plus 4. Using intuitive idea. Intuitive idea is, intuition is one knowledge that we have in your brain, and you don't know very well that you have. Entonces, you predict without mathematics, without nothing, you predict. What do you think about the first one? The first one is even, that we have 3 possibilities, even, odd, or neither.
Even.
Es obvio que es even because the exponent is even, pero no always happen. But in this case, a linear combination. Es plus, 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 or minus. But okay, the formal way, get one, you show me in the test is you are doing reflection. And when you are doing a reflection, according to the theoretical part, nothing happens. It stays the same. In this case, the exponent is 2, is even, is 6, is even. The actual value is also even function. Do you remember the graph of the actual value that look like that? Actual value function, y equal actual value function, look like that. This is a classical even function. Because when you are doing reflection, chuk, 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 it stays the same, right? That part, when you reflect, become like that part. And that part, when you reflect, become the other. So you are doing reflection and nothing happens. Entonces this is f minus x is 3x squared, because this negative we can interpret it like a -1, and -1 squared positive 1. This is exactly the same, and actual value negative quantity is positive 1. And when you compare the green one and the original, it's exactly the same, twin brother, therefore the first one was even. What do you think about the second? This is number 1, this is number 2, this is number 3, and this is number 4. What do you think about number 2? Using intuition, even, odd, or neither? Neither. Very well. Why? Because when you replace x for negative x, the first one change. The second change. But the last one stays the same. So the answer is minus x cubic, opposite sign, nice. Minus x, again, opposite sign, nice, but this stays the same. And when you compare the blue and the original, it's not twin brother, even. It's not totally opposite sign, odd. Therefore, it's neither. It's the number 3. What do you think about number 3? Receiving, intuition, odd, or neither? Odd, very well. Jovino Romero is good. Entonces, remember you are doing reflection. In this case, in the top part, change. Because it's negative, at this point is odd. But in the bottom, no, stay the same. Therefore, you have, this is positive, but this is negative. And this negative, if you want, put it in the top or put it in the middle, it's the same. And this is exactly the condition for the odd function. Remember, let me copy. Condition for the even. When you are doing the reflection, nothing happens. This is even. Condition for the odd. When you are doing the reflection about y-axis, is the same to make the reflection about x-axis. This is the situation we have in this example, because I introduced artificially one negative inside the parenthesis, and suddenly happened. I don't know why you put a negative outside the parenthesis. It's a classic. Otherwise, not present. Okay, super. Let me try the last one. What do you see? What do you think about using intuition, even, odd, or neither?
What was the answer on that one though? H of x.
What is it? What?
What was the answer on the last question we just did?
The last was odd. Why? Because it's this minus indicate like a this minus. Okay? When you compare our expression after the reflection with the original before the reflection, I can see, oh, no twin brother, no, but they are family because we have a minus in the front. This minus is this minus. Oh. Got it?
No, I thought negative x cubed was a negative x though.
It's because negative x cubed, you can interpret in your mind like a negative 1 cubed and x cubed, no? And negative 1 cubed is negative x cubed. This negative stay here or here. What do you think about the last one? Even, odd, or neither?
Yeah, so wouldn't the final answer be negative x cubed over x squared plus 1?
Yeah, I know. The final answer, the final answer is both. It's the expression and the classification. We have, my question imply two answers. The final answer after the reflection and looking this classification. Okay? Something weird? No? Okay. The last one, nobody.
I guess I'm still not getting it. I'm sorry, because shouldn't the circled answer be negative x cubed over x plus 1, which would make it neither because it doesn't match anything?
No. This is odd. This is odd. Maybe you understand why it's odd. I try to explain. Look, this is different to this. This is a little bit different to this. This is, look, this was neither because it's positive, and this is negative, positive. But this is different because it's linear combination, it's addition, blah, 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 or subtraction. In this case, no, in this case, division. And you need to know that when you have a fraction like that, fraction, numerator, denominator, and suppose that somehow for one reason, this guy is negative. Entonces, you put a negative in the front. Okay. And when you compare, my original expression was without transformation, numerator, denominator, no? So you compare this and this, well, you see, wow, we have one extra negative. But one extra negative that belongs to the entire expression, no one specific. Okay? So it's important that you understand, for example, negative 5 over 4 is equivalent to say 5 over negative 4. It's the same. Or minus 5 over 4. In my opinion, this is the best elegant way to write when the fraction is negative. Okay, so this negative in the front is like a one invisible, negative 1 can multiply the entire expression. It's exactly the definition for the odd. The definition for the odd is when you are doing reflection inside the parenthesis, get y-axis. I don't know why it happened. Okay, now this reflection is equivalent, it's the same of the another reflection that is negative outside. This negative is negative. This negative was this negative. I don't know if it's good or not, the explanation. Sir, it's okay or no?
I don't want to hold up the class. Go ahead and go. Thank you so much.
No, it's okay. Okay. Entonces, the last one was even, odd, or neither. Using intuition. Remember, intuition is an all is even. Okay, because when you are doing the reflection, any exponent is, is even, no? Entonces, minus x squared minus x to the 4th power plus 4, no? This is positive, and this is also positive. And when you compare this and this, twin brothers. Here's the definition for the even. Even is when you are doing that reflection, nothing happened. Nothing happened. And this is the important property of the sum function that contain even exponent, no? But in this case, contain even exponent and odd exponent. Okay? And if you contain even odd and odd exponent, suppose another extra example. Suppose the function m is x cubic or to the fifth power plus 4. What do you think? Even, odd, or neither? Using your intuition and imagination. No idea? No problem. So you have no idea, you are doing the procedure. Okay, make a reflection. It's neither. Yeah, you're right, Jovino. Jovino says neither. Look. This is minus x cubic. This is minus x to the fifth power plus 4. It's minus x cubic over minus x to the fifth power plus 4. When you compare this and this, no equal, no even, no totally opposite sign, okay, because this minus, you can write here in the front if you want, but the bottom have minus, but have positive. So there are no possibility it's the same. That possibility is the same if this 4 become negative, but it's impossible in this example. This is neither. Confusing or more clear? Clear or no clear? Unclear or clear? Honestly, no, honestly. Clear. Okay. Si it's not clear, I try to bring next class more example for the neither. I want to find sophisticated. You want I bring more example or no? Or not necessary? We focus on another topic. Okay, I bring. Let me try to bring sophisticated example to determine when you have the expression. But basically, the only thing you should do is you are doing reflection. You know that this action, when you put instead of x, you put negative x, we are doing reflection. Reflection. With respect y axis. In other words, suppose one curve like that. Like that. Okay, you are doing reflection. Reflection means that part go to the positive part, and that part go to the negative part. Well, it's similar. No, it's no good example. Well, it's a reflection. When you are doing the reflection and nothing happened, stay the same. Classical example, parabola. Classical example, absolute value. And any power function when the opponent is even, suppose x to the 4 power, absolute value is typical. And they are combination, but somehow, no linear combination maybe work, but no always work. This is the even. What about odd? Odd is when you are doing the reflection, this reflection is equivalent to make a reflection with respect this is reflection about y. This is a reflection about x. The classical example to understand this, look, is the y equal cubic function. Let me write 2 times. When you are doing reflection about y, let me using blue color. It's like that. However, see, you are using reflection. This was reflection with respect to y. Now we respect the x in green color. Okay, that part is now positive. That part is negative. Do you see that the green and the blue is the same? Yes or no? That is the reason que es odd. That the reflection in one direction is exactly the same of the reflection in another direction. In other words, in other easy and not sophisticated word, you pick one X here, you get one Y here. You pick the same value, but negative, opposite side, you get this segment is exactly the same of this segment, but in opposite direction. This is typical odd. Super. This is one kind of reflection. Symmetry, sorry, symmetry. One kind of symmetry. No clear, no clear, no clear. See, yes, clear. Okay, stop now. Time is over. Wow, we're doing too slow. Bueno, but we have, remember, according to the calendar, we have time, guys. We have next week, today is 8, October 8. Now, next week is, we have two classes, 13 and 15, and the test I collect is due October 20. So October 20, I start new chapter for the test 3. And the October 20 and May 9, I collect the test on paper. And also it's due the test online. Good? That part is clear or confusing? Clear?
Can you repeat again? When is it due?
Okay. Today is October 8. We are doing one piece of review, little piece. We continue the entire week, next week, to finish the review. Maybe we finish, or no, Tuesday, we finish Thursday, but maybe we finish early. Not necessarily we extend it to 7 o'clock. And then we take a break because we deserve, because we are good students, can understand everything. And October 20, this day is October 15, I send to you the test on paper by email, through email. You have the entire weekend, and October 20 is following next Tuesday is the due date at midnight as always for the test on paper plus. I appreciate so much that the test on paper you write clear. You are a student in college. You are not kindergarten guys. Okay? Clear. I need to understand. Si es, I don't know, si es 10 pictures. Okay, you send me to email, or si, or the students are doing very well. I don't know how. Well, I know. You convert the document in PDF. You take a picture, convert to PDF, entonces it's clear. When I open, it's super clear. It's white color. Okay.